All right, you guys. So in this video, what I want to do is dive a little bit into the multi-point localization with magnet field and a network connected rover. I am doing it on a simulator, so bear with me. I'm actually not walking outside because it's hard to make a video and actually have a person or people understand what I'm talking about and have a microphone on me and walk around. So I'll just make it in a virtual world. Uh, we'll call it multi-point localization. There we go. That's the name of the project or the job. Next, I'll be using a virtual Hyper VR network configuration. This is really important. So when you're used to working in a state like I'm typically working in these conditions when I'm in state plane coordinates, say I'm on a project that doesn't seem to match perfectly, and I don't want to be readjusting the control. I want to inherit the actual ground control. What I need to do, and it's not just a simple one-point transformation that fixes it, but it's a multi-point transformation that needs to be actually done. You have to make sure that you create your projection by having a say none. The datum, by nature of not knowing what state you're in, should be WGS84, and your geoid is going to also say none. So these are the prerequisites for the successful localization of a project if you are not going to be using state plane coordinates. I know you might be actually localizing on state plane coordinates because you know that those are not just local coordinates but state plane, but if the rotation and that shift is too much, consider it a coordinate system by its own, on its own. So that's why this says none, WGS84, and none for my geoid model for as far as elevations. All right, units, your choice. I don't really care. Display screen doesn't really matter. So I'll hit the green check over here. So currently, if I go into my map, I don't have anything in the map. If I go into points, I have nothing. If you have points that you are given by whoever's contracting you to do the work and they have the control on site, please do me a favor, hit the from file button, import your points in whatever format you're given those coordinates as. But in my case, I do not have points. And again, this being just a demonstration video, I will create some points. So I'll go into calculate, and I'll hit enter plan. And under enter plan, I can just type in some dimensions and it'll just work. So I'll keep this first direction going north. We'll call it 100. In my case, it's feet. It could be meters. It doesn't matter. Let's go in 90 over here. We'll go, I don't know, we'll make it different. We'll make it, say, 150 feet or something. And we'll hit OK. And then we'll go 180. And we will go 100 feet again so that we close this. And we'll store this. And then we will just do a nice closure on our line. Let's save. So we have a actual map of a rectangular project area, and I'm imagining that the project is happening inside this. So next, what I'm going to do is, because this doesn't have any relation to the GPS, I will still connect my GPS. You would now physically actually take your rover to those points on the ground. You understand that they would be somewhere over here. I am not doing it because this is a simulator, so I apparently appeared somewhere over here. So that's close enough for me. But I am fixed. I am happy. My position, though, is an arbitrary 00 latitude longitude, right? So I would now go ahead and actually go into my setup screen. And under setup, there's a button that says localization. And under localization, it's kind of grayed out because it understands that you're in local coordinates and you're using WGS84 as your datum. So we'll hit add. And what I'll do is I'll actually pick my first point, and we'll say if it's point number 1000 is what I just walked up onto. And maybe I'll back up one step here. What you should be doing when you're doing localization, you should never just take one measurement with your GPS. You should take a couple. And in order to do that, you go into your configure button and maybe change this value over here to 60 readings or 30. There's no industry standard there. Longer is better. Again, this being a demonstration, I am actually going to keep it short and I'll make it one, but you shouldn't be making one reading for your precise or your quick measurement when you're doing localization. So make sure this is higher than just one, but for me, I'm happy with it. We'll hit add. We'll go to point number 1000, and this is where it gets a little bit tricky this is your known point. So we know the coordinates of this point are whatever they were when we actually created them. So actually, I can look at the coordinates, and apparently they're 5,000, 5,000. So that's the point that I'm actually occupying, 5,000, 5,100 right now. The measured point is me walking up onto that point, and that point is going to be something different. So I'll call this 1,000 just so that I understand, and maybe I'll call it LOC for local point. So this way, when you hit the store button, this point will not override this one, and I'm actually duplicating, and there will be 2 points in my localization this way already, married to each other as one known point and one measured point. I'll hit the little take measurement button over here. And again, bear with me, I am actually right-clicking and setting my simulator over here. In your case, you'd actually physically be moving on top of that nail that you know point number 5,000, 5,100 actually inherits. So we'll go here and I'll take a measurement. In your case, it might take 60 readings. Mine just took one, so I'll just hit OK. This is now saved, and when I hit the green check, you'll see that there will be now a report saying, okay, we have a known point and we have a measured point, and their relationship is perfect currently because obviously we don't have any means of calculating some residuals yet. So next, we'll go ahead and actually do this same thing. Again, we will pretend that we're walking up to point number 1001 over here, and we'll call this 1001 LOC. And once again, I will pretend that I actually walked there. So we'll right click and I'll say set my simulator here. And we'll, as soon as I'm plumb over top of my point, I'll hit the record button. I'll store it and we'll hit the OK button. And we start seeing some residuals. They should equal each other out because the coordinate system is not defined by 2, but at least 3 coordinates over here. So I have 2 points. Let's keep on going. So my second point or my third point over here, we will say we are occupying point number 1002. We are going to be walking up to it, so, and we will store it as 1002 LOC. Once again, I'm not going to be precise on my placement of the actual rover pole over here, but you get the idea. If you're not precise, that's what we'll calculate, or imprecision. So we'll store this, hit the OK button. Record. Now you can start seeing horizontal drift already. That's my mouse and you not moving up onto the point that is actually occupying the known point. Let's go on our last point over here, point number 1003. We'll hit record, 1003, 3, and LOC. Hit that. Once again, I will just pretend that I walked up to this thing. So, oops, too close. So we'll go set my simulator. You would have walked up on it. I'll record it, hit the OK button. Now I have everything read into my actual position. Now you can see your horizontal and your vertical residuals. And now these residuals are something that you have to inspect, and you have to inspect them to a degree of accuracy or degree of tolerance that you're willing to live with. I am definitely not willing to live with 600s or 6/10, 8/10, and 4/10 of a foot. So this is where you can go into each individual of these measurements already and say, you know what, I don't trust the horizontal value here, and it'll rebalance. And you say, that didn't really get much better. So let me go back in here and say use horizontal. The vertical seems okay. Again, in the simulator world, this isn't really simulated very well, but typically you take out the highest value. So obviously this is the highest value. So if I hit use for horizontal, it takes it out. So apparently I must have read that position incorrectly. If I can't do it better, then you don't have to redo it. But if I know I can do this better, what you can do is you can actually highlight this and say, you know what, I want to remove this completely. We'll say yes. And what I'll do, I'll try to do this again. So we'll go in here. We'll say we're once again on point number 1003, and we will reshoot it. We'll call it 1003 LOC, and we'll call it 1 because LOC already exists and it's a bad position. So we'll go in here and I'll zoom in on it a little bit tighter so that I'm pretending that I'm actually more accurately setting my pole here. So I'll hit this, hit OK, wait for it to take the reading, we'll hit OK. And then now you'll see, well, I'm still off, but I'm off by less. So if I go here, you can see that these 3 were really accurate. This one was still not very accurate. And again, I can go ahead and actually just remove this, saying I still don't like it because somebody walked up on me and I moved my pole, or my GPS was under a tree. I might have to actually change the position of my rover. Let's go see. Let's try this third attempt over here and just get it way closer. Again, at this point, this is where I'm trying to be a half a foot or better. So we'll go here, we'll hit set, and we'll just record this now. We'll store it, and you'll see that these values are now going to be much tighter. Again, I'm pretending, I'm simulating that I am adjusting the position of my rover pole over top of the actual known point. Once I'm really happy with these values, which is now, I can just hit the home button. And when I now go into my survey and topo, as you move your pole around, so if you move into the center of your project, you will see that your northing, your easting, and your elevation is in relation to the actual localized points. And if you don't like your localization, you can always readjust it. Please, 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 and sorry if I say it too many times, do not readjust your localization after you've surveyed points in. So if I survey a point, see, I'm in demo mode, I can't even survey another point. Let's go ahead and actually delete the ones that we know we don't need. These we measured incorrectly, so we'll hit this point. If you survey a point in the middle of your project after you've localized, and then you decide you want to change your localization, it'll readjust all of your points. So be careful. Don't just go ahead and start turning off things, because when you go in here and now you start editing and not using for control, you'll see that there will be a shift in your actual coordinates on those points. So be careful. But otherwise, this is the quick way of, I guess, explaining how localization works in magnet field. If you have any questions or comments, leave them below.